Erupting magma initially forms a layer of material which looks much like a dome out of pillow lava. As eruptive activity continues, the heat melts significant volumes of overlying ice, creating a thick glacial lake in the volcano. After the glacial lake develops, eruptive activity shifts to a more explosive phase, depositing a rock type known as hyaloclastite. If this eruption occurred from a singular primary vent rather than a fissure and stopped at this point or a prior phase underneath a glacier, the resulting landform would be known as a subglacial mound. However, things change if the eruption continues. Over time, the erupting vent, which now has an unusually steep profile, breaches the surface of the lake, causing eruptive activity to change once again. Instead of being highly explosive, more effusive to moderately explosive eruptive activity occurs, sending lava flow to fill the area previously occupied by the lake. The movement of the lava is partially constrained by the presence of the glacier, forming a flat-topped edifice. If that entire sequence occurred from a singular primary vent, then the resulting landform would be called a tuya. However, if the subglacial eruption occurred from a fissure vent, regardless if it had a lava cap or hyaloclastite, the resulting landform would be called a tindar. Some volcanoes do not have a large central edifice, but merely mark large craters in the marsh ground. Take for example this giant explosion crater at the Soda Lakes volcano in Nevada. This complex consists of two explosion craters, one of which is 2 kilometers wide. These craters are referred to as Mars, and form when rising heat from a body of magma encounters groundwater at depth. The groundwater then flashes to steam, builds in pressure, and explodes upwards, forming a Mar crater. Tuff ring and tuff cone, a similar volcanic feature known as a tuff ring, forms when the same process takes place, but instead with a body of water on the surface. When this occurs, an explosion crater is generated but is not as deep, and has a highly rounded ring of debris at the crater's edge. For example, this is the Haverfjell tuff ring in Iceland, which represents a prior vent of the Krafla volcano that formed 2,500 years ago. However, if repeated explosions occur over a longer duration, then a tuff ring might build in volume to become a tuff cone. Technically speaking, if a volcano contains a wide series of vent types, complex volcanoes such as multiple stratovolcanoes, lava domes, and related vents which are closely spaced, you form what is known as a complex volcano. One example in the Tongariro volcano in New Zealand. If a volcano contains multiple vent types but with no or very few exceptions, each vent only erupts volcanic fields once, then you have a volcanic field. It is best to describe a volcano, in my opinion, based on its most prominent or largest feature, as most volcanoes contain multiple volcanic landforms. For example, classifying complicated volcanoes, while the Darwin volcano in the Galapagos Islands contains a shield volcano, caldera, cinder cones, and tuff rings, since the largest portion of the volcano is a shield volcano, I would classify Darwin as a shield volcano. As a final note, I would like to thank my new YouTube channel member Hussein Tamer for